Hello class, today we're going to go ahead and look at section 6.6. It's our last section in chapter 6. We're going to be looking at solving polynomial functions. Solving polynomial functions is very similar to how we solved quadratic equations. If you can remember, we would factor and then we would use a zero product property. So we actually will be doing the same thing, except for now we're going to be able to factor polynomials as well. So we want to factor the following quadratic equations just as a little bit of a review. So number one, okay, there's two ways to go about number one. Okay, I recommend reverse FOIL. So what you would say to yourself, well, what multiplies to 2x squared? Well, that's nice because 2 is a prime. So I know that 2x times 1x will give me 2x squared. And then I think of my factors of 15. And just 2 off the bat would be 3 times 5. Okay, so then I would say, well, does 3x, and I multiply these two, 10x, is there any way that that can get me to negative 7x? If my 10x is negative, then yes, it will. So this would be negative, and this would be positive. There it is factored. Okay, this is the quicker way to factor, and I highly recommend if you're thinking about going into pre-calc, trig, that kind of thing, work on your reverse FOIL technique. Otherwise, the other method is grouping, and that will also work just fine. But you take your A term times your C term, so you take 2 times negative 15, which gives me negative 30. And then I think, well, what multiplies to negative 30 but adds to negative 7? Well, negative 10 and 3 do. Okay, so then I go ahead and rewrite this. I would write 2x squared minus 10x plus 3x minus 15. Okay, and the way we can do this is because negative 10x plus 3x gets us back to negative 7x. Then we go ahead and group. We look at the first two terms and the last two terms, and I see, well, what can I factor out of both of them? I can factor out a 2x out of the first one, minus 5x, or sorry, just minus 5, plus, and I can factor out a 3 out of here. Then I look at both of these. Well, this has an x minus 5 and this has an x minus 5. So I would have x minus 5 times whatever is left. So this method is by grouping, and if you notice, I got the same thing as when I did reverse FOIL. So whichever technique you want to use, it's up to you, but there is both techniques. Number two. Okay, it says to factor this one. First thing I notice here is that it's not a quadratic, so I just say, well, what can I take out of each part? So I think of my greatest common factor. Well, 25 and 5 are both divisible by 5. If I have a to the third and a squared, I can take out an a squared, and b to the fifth and a b to the sixth, I can take out a b to the fifth. You always take out the lower one, okay, the lower exponent amount that they have in common. So I would say 5 times what gives me 25? Well, 5 times 5. A squared times what gives me a to the third, so a. B to the fifth times 1 would give me b to the fifth, so that's all I have there. Plus 3 times what gives me 15. Sorry, 5 times what gives me 15, 3. A squared times 1 gives me a squared, and b to the fifth times b gives me b to the sixth. And there that one is completely factored. And our last example on for review is number 3. I have a squared minus 81. One thing to notice that this is our difference of perfect squares, because the square root of x squared is x, and the square root of 81 is 9. So remember, when we have difference, it has to be subtraction. You can write it as x and 9. I'll have 2 parentheses, and then one's always plus, one's always minus. There it is, factored. The other way you can think about it is, it's really x squared plus 0x minus 81. Well, 9 times negative 9 multiplies to negative 81, but when I add them together, I will get 0. So there's my difference of perfect squares. All right, so when factoring polynomials, always make sure you take out the GCF first, that greatest common factor. GCF. Okay. Then factor the results if possible. Okay, so here's some special factor patterns of polynomials with two terms. Okay, difference of two squares. We just did that example. That was example 3 on the notes. Okay, the next one, if you notice, these are cubics, or they have a to the third, b to the third. So these are difference of perfect cubes, but one is the sum and one is the difference. So if it is addition, okay, we need to figure out what a and b are, okay, and then it's going to be a plus b, and then in parentheses, it's a squared minus ab plus b squared. Then if it's subtraction, your first set of parentheses has a negative. But then notice everything else inside of here is positive. Okay. So you just have to try and remember the pattern. One thing I would remember, if it's plus, the first set of parentheses has a plus sign in it, and then I always remember that this will be negative. And then if it's subtraction, my first set will have a negative and everything's positive. So it's kind of the short set of parentheses, the binomial, looks the same as what I had to begin with. And then the quadratic or trinomial will have the opposite sign in it. Okay. So let's just go ahead and look at some examples. Okay, we want to factor the following polynomials. The number 4 and 5 hint is it's a sum or difference of cubes. So you can look at your note sheet above and see the sum and difference of two cubes. So if I look at 4, since it's addition, it's a sum of two cubes. So what I would do is, to help myself out, is I would figure out what a is and what b is. So what I do is I take the cube root of each piece. So this means that a is equal to x, and b is equal to the cubed root of 125 is going to be, well, that's 5, because 5 times 5 times 5 will give me 125. So then to go ahead and write it out, remember, it's going to be x plus 5, my a plus my b, since it was a plus. Then it's going to be my a squared, so x squared minus, now I multiply the two, 5x, and then plus my b term squared, so 5 squared, which is 25. And there it is, factored all the way. Now I go ahead and I look at 5. It's a subtraction sign, so this is the difference of two cubes. So you can look at your table above and see that. So once again, I would recommend figuring out, well, what is a and what is b. So I take the cubed root of each piece. So my a, well, the cubed root of 8 is 2, and the cubed root of x cubed is x. And then my b will be the cubed root of 27, which we know is 3, because 3 times 3 times 3 is 27. So, same idea. I take my a plus my b, a difference, so I'm going to subtract. So it's going to be my 2x minus my b. Then again, the next part is the same, but I'm going to have all positives or pluses in between. So I would take a squared, okay, so I would square each part in a, so I would have 4x squared plus, take a times b, 6x, and then plus my b squared, so 9. And there, this is factored all the way. So here was just our table to use as a guide, but you guys have it at the top of your note sheet. Let's go ahead and look at 6 and 7. So their hint for this one is difference of perfect squares. Well, for this, I would say the square root of a squared will give me a, and the square root of 49 gives me 7. So remember, it's just going to be a plus 7 and a minus 7. And I look, is there anything more I can factor on that? No. Okay. 7. I say, what's the square root of x to the 4th? Well, that's going to give me x squared. And then what's the square root of 81? That's 9. And then remember, I always have a plus and a minus. But you need to be careful in this case because x squared minus 9, that's also another difference of perfect squares. So I'm still going to have x squared plus 9 out in front, but then I have to factor this down even further. So I would say, well, the square root of x squared is x. The square root of 9 is 3. Then I always have a plus and a minus. Now it is factored all the way. Okay. Moving on, 8 and 9, hint. Factor like general trinomials. So what this is saying is if you notice, and it looks like it's really x squared squared minus 2/3 to the x squared minus 50. So if you notice, it's kind of in the form, okay, of my quadratic. So factor it like a quadratic, but since it's an x to the 4th, I'm going to have an x squared out in front, because x squared times x squared will give me that x to the 4th. And now all you have to say is what multiplies to 50, okay, but adds to negative 23. Well, my factors of 50 that I think of right away are 25 times 2. And if this is negative, negative 25 plus 2, that will give me negative 23. And when I multiply them, I also will get them to be negative 50. And then I go ahead and look at this, and I see that x squared minus 25, once again, difference of perfect squares. So the square root of x squared is x. The square root of 25 is 5, and I always have a plus and a minus, and I still write the x squared plus 2. There it is, factored all the way down. Number 9, same idea. So it's an x to the 4th, so I'm just going to think about it as having an x squared term in the front. And so I say, what multiplies to negative 63, but adds to 2? Okay, well, 63 right away, I think of it as 9 times 7. Okay, so 9 times 7. And could they have one of those add to 2? Well, if I have a positive 9 minus 7, yes, it would. Then I look, is there any difference of perfect squares or anything else I can factor? This is an addition sign, x squared plus 9, so that will not factor anymore, and 7 is not a perfect square, so we are done. Okay. Solving quadratic equations using quadratic techniques, that's essentially what we just did in our last example. So if I have x squared plus bx plus c, you would just say, well, what multiplies to c but adds to b? Okay. And then it's the same thing here. If I have an x to the 4th, we just break it apart to x squared and x squared. That's the only thing that's new. Same idea, though. It still has to multiply to c and add to b. Okay. So now we're actually going to do the solving. Okay. So solve each equation by factoring. Well, I look at 10 and I see it's a quadratic, so I just go, well, what multiplies to negative 14 but adds to 5? Well, I know 2 times 7, or 7 times 2 gives me that, and it would be, well, can I get them to add to negative 5? If I have negative 7 and positive 2, that will add to negative 5. Now remember, we use the zero product property. So I go and I set each part of the parenthesis equal to 0, and I solve each part. These are my two solutions. Okay, so that's example 10 with solving. Example 11. Okay, if I look at example 11, this is it looks like a quadratic, but it's really an x to the 4th. So I just start out by x squared in my parentheses, and I say, well, what multiplies to 36 but adds to negative 13? Well, 3 times 12, that's not going to give me 13. How about 9 times 4? Well, 9 times 4 will give me 36, and if they're both negative, they will add to negative 13. And then I go ahead and I look at this piece, and I say, oh, wow, well, they're both difference of perfect squares. So this first part, I would say, well, the square root of 9 is 3, so I have a plus and a minus. And then if I go ahead and look at my second part, okay, the square root of x is x, the square root of 4 is 2, and there's always a plus and a minus. And now I go ahead and solve. I set each part equal to 0 and solve. So I get x equals negative 3, x equals positive 3, x equals negative 2, and lastly, x is equal to 2. So I have 4 answers for that one. Okay. Let's go ahead and look at number 12. 12, once again, looks like a quadratic. Okay, it's in that quadratic form, but I have an x to the 4th, so I can go ahead and use the same technique. Just going to have an x squared out in front. And once again, I say, well, what multiplies to 225 but adds to negative 34? One thing that I noticed is that 225, I could break it down into quarters, 25 cents. So I would say, well, how many times 25 times what gives me 225? 25 times 9. And could I get to negative 34 with that? Well, if they're both negative, I can. Okay. Now I notice, like example 11, number 12, these are both difference of perfect squares. Here's a second method to solving this. I could just say x squared minus 25 is equal to 0. Okay. And I could say x squared minus 9 is equal to 0. And I could solve this using the square roots. So I would add 25 to the other side. And then the other way I can do this is taking the square root of both sides. So x is equal to, and remember when you take the square root, you have two answers, plus or minus. So it's plus or minus 5. Okay? Or you could have did difference of perfect squares and solved again. But this is another way that you could have solved 11. And same thing here, I would add 9 to the other side, take the square root. So I get x is equal to plus or minus 3 when you take the square root. Okay, so my answers for number 12 would be x is equal to, well, negative 5, negative 3, 3, and 5. And our last example on here is number 13. Okay, and I look at this and I see that it is a cubic, and it is, well, they're doing addition. So this one would be a sum of 2 cubes. So this would be the example because it is addition here. So what I would do is figure out, well, what's A and what is B? So once again, A is, well, what's the cubed root of x cubed? Well, x. B, what's the cube root of 64? Well, 4 times 4 times 4 gives me 64. Then I'm going to go ahead and use this guy right here to factor it. Well, it's A plus B, so x plus 4, times my A squared, so x squared, minus x times 4, which is 4x, plus my B squared, so 4 squared is 16. Now what I would see is, well, can I factor this any further? Well, it multiplies to 16, but adds to negative 4. Well, my factors of 16, 1 times 16, 2 times 8, 3 times nothing, and 4 times 4. Is there any of those values that I could get to add together to be negative 4? There is not. Okay, so what I would do is I take my first part, and I solve this. This gives me x is negative 4. Then I need to go ahead and use our favorite quadratic formula on this piece here to figure out my other solutions. So remember your quadratic formula. Okay, it's x equals the opposite of b, so b is negative, so positive 4, plus or minus the square root of b squared, minus 4 times my a times my c, all over 2 times my a. So if I go ahead and simplify what I have underneath my square root sign, I should get that this is negative 48 over 2. And then I would say to myself, well, what is my perfect square in negative 48? Well, 16. And remember, whenever I have a negative underneath my square root sign, remember that the square root of negative 1 is I, the imaginary number. So I'm going to put I out in front, so it's really 16 times 3 gives me 48, all over 2. Okay, and then I'm going to simplify again. So I'd have 4 plus or minus, the square root of 16 is 4, so it's 4i square root of 3 over 2. And then I can divide each part by 2. So 4 divided by 2 is 2, 4 divided by 2 is 2. So my solution would be x is equal to 2 plus or minus 2i square root of 3. Okay, along with my other solution that I found from before, x equals a negative 4. So this is, remember, a real solution. This is an imaginary. But I would want you to give me all solutions, so you would give me all the solutions. Okay, so those would be my answers. All right, so we're going to go ahead and stop the video. Please make sure if you have any questions, you write them down. If you need a little more help with factoring, I would highly recommend just Googling factoring practice, and you will, I'm sure, find plenty of worksheets that have solutions, or come and talk to me. Have a nice day, and I will see you later.